Hi, I'm Brett. I'm one of the biology lab techs at PCC Cascade, and I also teach a little bit part-time. I'm here today to show you a little bit about some of the basic measurement tools that we have in our biology labs, even though we can't be in the biology labs right now. I brought a bunch of stuff home. Unfortunately, I didn't bring a whole lot of glassware home because I didn't want it to break, but I have some plastic stuff and a few glass pieces that I can show you how to work. So if we pan over this way, we see a couple of beakers. We have a 1 liter or 1,000 milliliter glass beaker. And we have a 250 milliliter plastic beaker. Beakers are great for holding fluids and approximate measurements. So if you want to measure approximately 500 milliliters of water, you could just use the markings on this beaker, and that would probably be close enough. However, if you need an accurate measurement, like when you're mixing up a chemical or running an experiment, you want to use a more precise tool for measuring, and that would be a graduated cylinder. So I only have one graduated cylinder. It's a 1,000 milliliter or 1 liter graduated cylinder. Can you see that there?
1,000?
All right. So, so this is a much better tool for measuring precisely. And let's say we wanted to precisely measure 1,000 milliliters of water. And I've got some water with green food coloring right here. You would just pour, and you'd want to keep your eye at the level that you're going to read. And when that fluid gets to that level, you stop pouring. There we go. Now we've got exactly 1,000 milliliters of water.
It's kind of at a slant. You can, but it's there.
Okay. All right, and now you can put that accurately measured water into the beaker.
And if you look closely, you can see that it's actually a little under 1,000 milliliters.
Yeah, so you don't want to
via the scale of that, but we know that that one is more accurate than that one.
All right, and thanks to my videographer / production assistant Henry for some of the commentary here. All right, so that's how to use beakers. Pretty simple, and those are kind of a standard lab tool that if you were in the lab, you would be using almost every week. All right, so graduated cylinders and beakers are great if you have a lot of liquid to measure and hold. But if we're dealing with smaller amounts, we're going to use some different tools. They make smaller graduated cylinders, which I actually don't have one right here. But we do have these devices called pipettes. And I've got a selection of pipettes here. Of various sizes. I have a 25 milliliter, which is just about the biggest pipette you will ever see, and a pump that goes with a 25 milliliter pipette. We have a 5 milliliter pipette, which is probably the most common size you'd use in the lab, and these green pumps fit that pipette. And then we have a 1 milliliter pipette, which works with the blue pumps. And the other thing I have here, this is just a centrifuge tube. It's like basically a plastic test tube. This one has some markings on the side, and again, these would be approximate volumes, not accurate volumes. Okay, so let's say we wanted to measure out exactly 5 milliliters of solution.
Wait, where's the 5 part?
So I don't know if you might be kind of tricky to see that. It says 5 on one side and 0 on the other.
Why?
Ooh, that's a good question. So there's two different ways you can use these pipettes. If you wanted exactly 5 milliliters, you would put the pump on, then put it into your fluid, and then use the thumb wheel to suck some of that fluid up until you get to the 5 milliliter mark.
Wait,
See that?
well, it's at a mark.
Yeah.
You can't really tell that it's a 5 mark,
Okay.
but
Trust me, it's the 5 milliliter mark.
I can
Okay.
see it's a 5.
And then there's two different ways to get the fluid out of there. You can either use the wheel again, or this little lever breaks the seal and lets the liquid out. And then that last little bit, you can use the wheel to get that out. Okay. So now we have exactly 5 milliliters of fluid in here. It looks like the markings on this are pretty accurate, but still not quite. The other way to use these pipettes is, let's say you had to deliver 1 milliliter of fluid to a bunch of different tubes. What you could do is bring the mark up to the 5 milliliter mark again, and here you could use the other marks where it says 0. You could go down to 1 milliliter, and then go to your next tube and go down where it says 2 milliliters, and then go to your next tube and deliver another milliliter. So you could either use these kind of as the full volume, which is one set of the marks, or the delivered volume, which is the other set of marks. Right. Of course, there's kind of a trade-off between capacity and accuracy with these pipettes. With the 25 milliliter pipette, it's in 2/10 of a milliliter. Each fine little marking here is 2/10 of a milliliter. The 5 milliliter pipette is in 1/10 of a milliliter, and the 1 milliliter pipette is marked in 1/100th of a millimeter. 1/100th of a millimeter.
Can you bring that closer so that those are like really small marks?
They are, and if you look very carefully on the markings here, it says 0 and it says 1, but actually that's 0.1, 0.2, 0.3, 0.4, and so on. So the 1 milliliter pipette is going to be the most accurate of these pipettes, but has the smallest capacity. Oh, this one's a finicky one. Okay. Apparently I should have brought a better pump home. So we won't even try and pipette with that, but basically works the same way. You would use the thumb wheel to suck the fluid up, and either the lever or the thumb wheel to release it. All right, so I've got a few more tools to show you that measure even smaller amounts of liquid. The first one is this transfer pipette, and this has some markings on it that aren't very accurate. These are good if the lab instructions say a dropper full, or if they say drops. This is a good tool for that. So you can get some liquid into that by squeezing the bulb, putting it into the liquid, and then we have a bunch of water with green food coloring, and then we could add it drop by drop, or you could add a whole dropper's full. Right. The last tools that I'm going to show you are called micropipettes. These again measure very small volumes, but much more accurately. So I have 3 different sizes of micropipettes right here. This one is a 100 to 1,000 microliter micropipette. This one is a 20 to 200 microliter micropipette. And this one is a 5 to 50 microliter micropipette. Micropipettes always need to be used in conjunction with a tip, and you need to make sure to use the right tip for the micropipette you're using. So with the 100 to 1000 microliter micropipette, I'm going to set this to, right now it's set for 1000 microliters, and I'm going to set it for 500. So you just rotate the dial to change the numbers until they read what you want. On these ones, you have to multiply the display by 10. So when it says 50 on the display, it's really 500 microliters that you're reading. And now I'm going to seat a blue micropipette tip. So these are the larger ones. The smaller ones won't even fit on the larger micropipettes. So now I've picked up this blue tip. And the micropipettes have two different stops. So with the plunger, you can go to the first stop, and that gives you the volume that you've set it for. If you go to the second stop, that there's a little bit of air reserve that can push the last little bit of fluid out. So now I'm going to get some fluid. This is just water with green food coloring in a microcentrifuge tube. So these hold about 1.5 milliliters total. And I'm going to get 500 microliters of that. And so I'm going to go to the first stop, put the tip into the fluid, and then gently release. And now I've got 500 microliters of that fluid in the tip. I'll get a clean microcentrifuge tube and put the 500 microliters into that. And then when we get to the end, there's a little bit left in the tip. So if you go to the second stop, that gets that last little bit out. All right, now we have this tip that has possibly been contaminated in some sort of solution. This is just water with food coloring. But if you don't want to cross-contaminate, you want to be using a fresh tip for every fluid transfer. So to get rid of the tip, you use the eject button on the micropipette and just find a suitable container like a beaker or a tip disposal container and press that button, and now you can get another tip onto that same micropipette. Okay, to use the 20 to 200 micropipette, this one is set for 200 microliters. What you read is what you get with this one. We need a different size tip, and these yellow tips hold a maximum of 200 microliters. And again, you seat them just the same way. You want to be sure to close the boxes of tips, especially if they've been sterilized, so that we don't contaminate those. And now I'm going to take 200 microliters from this solution, and the pipette works just the same way. And now you'll notice that there's almost no room left in the tip. So these yellow tips can't really hold more than 200 microliters. And we'll get a fresh microcentrifuge tube, and we'll put that into there. Okay. Oh, I got a little... there's a little bit that didn't make it. Poor technique. So you do have to practice with these a little bit. All right. The last micropipette is the 5 to 50. The volume adjustment on these is a little bit different. It's the plunger knob. And when you're setting these, you want to make sure you don't go below the minimum reading. So I can turn the numbers so that they go below 5, but you don't want to try and measure like that, and you don't ever want to force it because that could damage the micropipette. So I'm going to set this to 25 microliters. And these are a little bit more accurate since it's a smaller volume. So here you can see it says 25.0 microliters. And we're going to transfer that into a smaller container. So we have smaller containers than these microcentrifuge tubes. We have these PCR tubes, which are 0.2 milliliters or 200 microliters total. So these are for very, very small volumes. And now I'm going to get 2 or not 200, 25 microliters of this green food coloring and put it into a clean microcentrifuge, or no, not a microcentrifuge, a PCR tube. And again, it just works pretty much the same way. You gently dispense and then go to that second stop to make sure you've got it all. So there we have 25 microliters of fluid in there. And we'll eject the tip. And those are micropipettes. Hi, I'm Brett. Good to see you again. Sorry for the extreme close-up, but I did want to show you a couple more things. I wanted to show you some balances, and we'll need to take kind of a closer look at what the buttons say and what they're reading. So here I have two different balances. These are not quite exactly the same as the ones we have in lab. These are cheap ones from Harbor Freight. But they work basically the same way. So you can see that on this one, the capacity says 5,000 grams by 1 gram. And then on this one, it says max 1,000 grams, D equals, I assume division, 0.1 grams. So this one has a greater capacity but is less accurate. This one is more accurate but has a smaller capacity. So there's kind of a trade-off between capacity and accuracy. All right, so the larger balance, you can see it says off, on / tare, T-A-R-E, which is basically meaning to zero the scale. And then mode, which changes the different units of measurement, and then calibrate, which we don't need to worry about. So we're going to go ahead and turn this one on, and you'll see that it reads 0 grams, hopefully. Maybe we'll zoom in on that. All right. When we're weighing things on a balance, we don't want to get what we're weighing on the balance pan itself. So we like to use these items, which are called weigh boats. And you can put those on the balance pan, and then you can put whatever nasty stuff or messy stuff into the weigh boat, and it's not going to make you clean the balance afterwards. But when you put the weigh boat on, you can notice that the weight increases. So it says 6 grams now. So to zero out the weight of the container, which could be a weigh boat, it could be a beaker, it could be really anything that you put on the balance, you press tare, T-A-R-E, and that zeroes it out. And so I have a few things that we can weigh. I've got some paper clips. You can see how much a paper clip weighs. Put that in the weigh boat. Oh, it doesn't weigh anything. So all those things that say, oh, a paper clip is about 1 gram, those are the big paper clips. Here I think it takes maybe 3 or 4. Yeah, 4 paper clips gives us 1 gram. So the other great thing about weigh boats is if you have materials that are going to slide around, let's say like some beans here, you can put those in the weigh boat, and that'll keep them on the balance pan where they're getting weighed and keep them from scooting around the lab bench or the floor. All right, so the smaller balance, we'll zoom in a little bit more here. Turn that one on. They make smaller sized weigh boats for smaller capacities. And here we can tear out we can subtract the weight of the container again. And now we'll try paper clips again and see how much they weigh. So 1 paper clip is 0.3 grams. So really 3 of these should be about 1 gram. Yeah, so 3 of them is 0.9 grams. So if we wanted to get an average, we could add like 10 paper clips. So that's 4, 5, 6, 7, 8, 9, 10. So 10 of these weighs exactly 3 grams. So that means that each one would weigh 0.30 grams if they're all the same. And because they're manufactured, they probably are very similar in weight. Okay, so we will tear that again just to be sure. Now let's say we were going to weigh something like beans. These are probably not all the same weight. So one of them weighs 0.3 grams. 2 of them is 0.5, so maybe that one was a little bit lighter. 3, 4, 5, 6, 7, 8, 9, 10. So 10 of these weighs 2.3 grams. It's really hard to see the decimal point there. But each one probably doesn't weigh 0.23 grams. There's probably a little more variation from one bean to the next than there is from one paper clip to the next. Okay, so that's how to use balances. Thank you.